Welcome back. R7 again. I have some rules for radicals in this particular video. The product rule first. If you're multiplying two radicals, basically what this says, as long as the root numbers are the same, so I have the nth root of a times the nth root of b equals the nth root of a times b. So what this says is that if your root numbers are the same, you're allowed to multiply what's inside the radical, okay? Product rule. Quotient rule. The nth root of a over b, all in one big radical, is equal to the same as the nth root of a divided by the nth root of b. So this allows you to, sometimes you like this form of it if you want to divide, if they're divisible. Sometimes you like this form of it if they're not divisible. Like in this example here, you see 7 is not divisible by 64. So what this is we're allowed to separate them into two different roots and simplify them that way. Pretty useful. And then we have the power rule. So you have like a root of a root. So if you have like the mth root of the nth root, and whatever's here is the same, right? The mth root of the nth root of a, you can simplify it to just one root by multiplying the two root numbers, okay? Now, let's try some of these. So I am allowed to multiply this. The square root of 6 times the square root of 54 is equal to the square root of 324, okay? And the square root of 324, well, it's 18. But if you're not certain what it is, you could break it down. I know that it breaks down to 6 and 54 because I just multiplied it, so 6 and 54. I know this could be 6 and 9. I have a pair of 6s, so you can stop there if you want, or you can continue to factor, but I'm going to stop there. I think we've factored enough. So I have a pair of 6s that can come out, and I have a 3 and a 3, so I have a pair of 3s that can also come out. And 6 times 3 gives me that 18 number. Square root of 324 is 18. 18 times 18 is 324. Now here, I'm allowed, because these root numbers are both 3, I'm allowed to multiply the cubed root of m times the cubed root of m squared. And when you do that and you add those exponents, you get the cubed root of m to the third. So we're looking for trios. Because it's the cubed root, I have one trio, so m is coming out. How do you feel? All right, so here I have the square root of 7 over the square root of 64, okay? I really can't do much with the square root of 7. There's no pairs, it's prime. We'll leave it as a square root of 7. But the bottom of 64 is a perfect square, and the square root of 64 is 8, so the square root of 7 over 8 is what we're looking for. Which one of these three was your favorite? Well, I got a few more. Let's try a few more. I'm going to erase this. I think you have the rule down by now. And let's just try a few more and maybe see if we can increase that rigor just a little bit. So let's try, example D would be the 4th root of A over B to the 4th. Example E would be 7th root of the cubed root of 2. And then let's do F. Let's do the 4th root of the square root of 3. All right. So here, let's see. This is equal to the 4th root of A over the 4th root of B to the 4th. All right. Can I bring out an A? No. There's only one A. There's not enough A's to bring out an A, so that would equal to the 4th root of A. Can I bring out a B? I can. There are 4 B's. And one of those B's, well, I only have one B to bring out, so we have one B, and I started with an even root, and I now have an odd exponent. And from even to odd, we need the absolute value. Now I want you to be cautious of this. That rule sometimes you're gonna see it not used. You're gonna be like, hey, why does that answer not have an absolute value? Well, one of the reasons is like the fine print at the beginning of the problems. If at the beginning of the problem, it says, assume all variables to be non-zero and positive, which you'll see that sometimes. It might say that here or there, and you would just see B as the answer, and you might wonder, how come that seems to me like it should get an absolute value? Well, if you ever seem like it seems like you think it might need an absolute value, look at the fine print up at the top and see if it says to assume all variables to be positive, okay? Because that'll get some students sometimes, okay? Just be cautious of that. So now I have a root of a root, and that's so easy. You just gotta multiply the two roots together. So 7 times 3 is 21. So I have the 21st root of 2. And I don't have enough 2's to bring it out, so that's it right there, boom. And here, I have a square root and a 4th root. So 4 times 2 is the 10th, 4 times 2 is 8. 8th root of 3. All right. Hope you like those rules. More R7 coming.